we should be able to get the same object as it is to us, rather than passing a value to a new variable and giving it to us. So I have given you a variable xyz. You give me the same xyz variable back to me with whatever changes you're supposed to do, because the function is supposed to do some processing. So you do your processing and give me back the same variable again. Alright. So here, one way to allow functions to modify the value of argument is using pass by reference. And in pass by reference, what we do is we declare function parameters as references rather than normal variables. So examples always are better. Another example here, add 1. So this is how you pass a reference with an ampersand. So I am declaring the reference as y. So I am saying this add 1 is going to be taking a parameter as a reference rather than a variable, regular variable. And whatever you are supposed to do in this function you are doing. So here what will happen in main is, this is your regular function, okay, a foo function declared as a reference to take as a reference as a input parameter, and when the argument is coming from main, see, argument will come as normal argument to me. Alright, so the argument is the value which is being passed to the function while making a call, right? We've done the arguments. So argument is passed in a regular fashion, nothing new here, whereas your parameters are going to refer to this argument instead of making a new variable out of it. Alright, so if x is coming to the function as a argument, x when comes here to actual foo will be referring to x only by the name y. So x is now called y also apart from x. So that same location in memory now is also y apart from x. Alright, so now the cout statements will make it clearer. If I say cout y, it prints whatever is passed in x, so basically 5, right? And when y is destroyed here, but when you come out and you say x is equal to something, it will still print 5 only. But it will not print 5, sorry, it will print 6, because in the due course of the function, y was made to 6. So y is not 5 anymore, y is 6. So when I say cout x here, after this foo call, after the call to foo, what do I get on the screen? I would be getting a 5 or a 6. Ideally, I would be getting a 6 because this is a reference. So it's referring to the same x. So if this reference becomes 6, it's ideally the same variable which is becoming 6. So this cout statement will now produce this will produce 6, okay, and not 5. So that is how your references work. Okay. Now this program is same as the one we used for pass by value example. So the same example is used here. Add 1 but with a reference as a parameter. Okay, now foo is getting a reference. Again in main I am calling add 1 with x, that is 5 as a parameter. Okay, and add 1 is doing what? Add 1 is incrementing it by 1. So x is coming to you as y as 5 and y plus plus makes it 6. Okay, and when we come back after add 1 and we display the value of x here, it will be 6, whereas in the previous call it will be 5. It's actually the same example. Okay. Now coming to the practical usages, where will we actually use them? Okay, sometimes we need a function to return multiple values. Okay, very ideal scenario. Generally, when you're doing some processing, you don't really return just one value. Your function would be doing some 5 calculations, and all those 5 values results have to be returned back. Now, with a single return statement, this is not really possible. Return just returns a single value. Okay, so the single value could be an array, but you definitely can't return multiple variables back to the calling function, which would be required. So if you see here, we have this function get sine cos. Okay, it's taking one double as a parameter, one double as a reference, and another double as a reference. So see here, this is very practical. In fact, most of your functions, your libraries used by C++ in the backdrop, in the background, are all making use of this particular scenario. These two variables here, your reference variables, are actually going to act as output parameters. Now, what are output? There's nothing as output parameter, meaning there's no technical term as output parameter, but here we are using the references to refer to the results that we want. So whatever is the result will be lost if it's an intermediate calculation of a function. That function, those variables exist only as long as the function is there in memory, the function is executing. The moment the function finishes execution, the variables die, their life is over. Alright, so what happens is, let's say here, we will take it from main to make it understand. We have two variables, double d sine, double t cos, set to 0 in the beginning, and then we call the function get sine cos with 30 as an input. So we want the sine and the cos of 30. So what do is, we have declared the function in such a manner that it will take an input from me, and whatever are the results, it will return back as references. So basically this main will create two variables, okay, and these two variables will be passed as an argument to your get sine cos function. Alright, and as an argument to get sine cos function, and this argument is declared as a reference here. So which means d sine is a variable, but it is referred as ampersand d sine, meaning its reference is passed. This could have been a new name also. Similarly, d cos is a variable here, but it's referred to in the function. So whatever the function does now, it returns the values. So it does a sine of dx, that is 30, and stores it in d sine. It does a cos of dx and stores it in d cos. The sine and cos are built-in functions. Okay, these are built-in C++ functions. If we have not really seen this, I'll probably produce a list of these functions for you in some session. Okay, so these are all built-in. Writing is a tedious task for me using this control. I hope you understand that. Alright, so what happens is d sine is having the sine of 30, d cos is having the cos of 30, and this d sine, d cos being references, they are returned back in d sine, returned back to main, and the main gets the value. So if you see, these references are used as output parameters to return multiple values. So you pass them empty, you pass them as 0, you just set them to 0 in the beginning, because here they are normal variables, but in the function they are actually references. So this d sine is referring to d sine variable, this d cos is referring to d cos variable. Again, these names could be a new name. I could have given the name as d sine e, d cos e here. It would still have worked in the same fashion. So this name can be the same name or a new name, all up to you. It will not really affect the working of the program. So this is where most of the times we use references. So for input, it's your choice to save on the performance, to save on the get the same variable back to the main function. You can make use of references, but for output, for multiple parameters to be returned back, references are a great candidate. It's a great candidate there, okay, and it's in fact used almost in every library function. You cannot have a function without references. Okay, now const reference. What are const references? One of the major disadvantages of pass by value is that all arguments passed by value are copied to parameters. They are had. They are copied. Arguments are copied into parameters. That is pass by value. When arguments are large structures or classes, which takes a lot of time, so we have references. Okay, when an argument is passed by reference, a reference is created to the actual argument, and no copying of values takes place. So there is minimum performance penalty here. However, there is another trouble here. Now see, The trouble here is since we're passing the same variable there, same copy, there's no copy created, it's the actual variable passed to the called function. The problem is this called function can modify this value, modify this variable, and make it to any variable. So what we can do is, to avoid this, in some cases, if the same variable is passed multiple times in multiple sources, okay, if the same variable is passed in multiple sources, what will happen is